This is problem number 4 on the sample test problems for test number 3. The rabbit population in a given field is being studied. When it was first counted, there were 100 rabbits in the field. 1 year later, the population was counted again, and there were 140 rabbits. A, assume that the rabbit population is growing according to a linear growth model. Give a description, either explicit or recursive, for Pn. So I've gone ahead and written the formulas down here before I started the video, so you can pause the video and copy them if you'd like, or just take a look at them in the notes. They're the same formulas. So we'll go ahead and start with the recursive ones. So recursive formula has two pieces. You've got the P0, it needs to be the initial thing, and then you've got the recursive rule, which is the more complicated one. So we'll go ahead and write down here, P0, initial amount. The initial amount in this case was the 100 rabbits. And then the formula for Pn, it's always Pn minus 1 plus the common difference. If I'm going to go from 100 rabbits to 140 rabbits, common difference is just how many rabbits we gained. And 140 subtract 40, subtract 100 is 40. So the common difference here is 40. The linear growth model assumes that every year you're going to gain 40 rabbits, just like you gained in the first year. And so down here we just put 40 for the common difference. And so in English, this says to get the population in a certain year, you look 1 year ago, last year's population, and you add 40. Again, that assumes that every year you gain 40, just like you did in the first year. It's real common for folks to try to replace this Pn minus 1 with some number in the problem. It's not supposed to. That Pn minus 1 is part of the answer. And again, in English, it says to get the population in a certain year, look at the population 1 year ago, and then add 40. Okay, more useful if we can find it is the explicit one. That's over here on the right. So the formula is always the same. It's the Pn equals the initial amount, still 100, plus the common difference, still 40, times n. N is just n. N is how many years you're looking into the future. So those are our two formulas. The two blue things are the recursive formula. The one purple equation is the explicit formula. You didn't need both for this problem, but I wanted to include both here in the video. Part B, according to the linear growth model, what will P10 be? Well, you can find P10 by adding 40 9 times, or maybe 10 times actually. Just keep adding 40 enough times, and that's basically what the blue thing says to do. You're using the recursive, which says just keep adding 40. But if instead of P10 we wanted P100 or P1000, I certainly wouldn't want to add 40 that many times. I'd much rather use the explicit one here. P10, according to my formula, is 100 plus 40 times n. N is 10 in this case. So we get 100 plus 400, 500 rabbits. Again, the explicit is a whole lot more useful if we can get it. Part C. Now assume the rabbit population is growing according to an exponential growth model. Give a description, either explicit or recursive, for Pn. Again, I wrote these down before the video started. You can find them in your packet. For the recursive one, they're here on the left. P sub 0 is the initial, same as up above. And now the recursive rule for an exponential growth model is Pn equals Pn minus 1 times the common ratio. Let's see if we can get our hands on that common ratio right now. So the common ratio is what number do you need to multiply the current population by to get the next population? In other words, if you start with 100, you end with 140, what did you multiply by to get there? And the way to find that is to divide. 140 divided by 100, always in that order. Second population over the first one. So 1.4, that's your multiplier. If you want to get from 100 to 140 by multiplying by something, you multiply 100 by 1.4. So we call it the common ratio because of the division that you see. So let's go ahead and see if we can fill in. So we'll put the recursive formula in blue again. So P0, initial amount, still 100. recursive rule now. Pn equals Pn minus 1 times the common ratio, 1.4, and we're done. In English, that says if you want to get a certain population, you'll look 1 year ago, last year's population, multiply by 1.4. That's assuming that every year you multiply by the same thing we had to multiply by in the first year. More useful to us, the explicit version, initial, still 100, times the common ratio, still 1.4, raised to the n power. That's the formula. And we're going to use that formula to answer part D. According to the exponential growth model, what will P10 be? So we just replace P10 equals 100 times 1.4 raised to the n in this case is 10. So we're going to do this one on the calculator. (100) times 1.4 to the 10. I didn't put parentheses around 1.4. You don't need them, but it doesn't hurt to put them in. So 10 years into this experiment, there are about 2,900 rabbits according to the exponential version of things. So we'll say about 2892.5. So 2 quick observations. It doesn't make sense to have 0.5 of a rabbit. Realize that. This model is just an approximation. Probably the first model was just an approximation too. So round it, it's okay. Don't worry about fractional parts of bunnies. And the other observation is take a look at the difference in the linear model, assuming we kept gaining the same number of rabbits every year. We end up with 500 rabbits after 10 years. If instead of gaining the same amount, we figure we gain the same percentage every year, then we end up with almost 3,000 rabbits. And that difference between the 500 and the 3,000 will only get more and more dramatic as this experiment plays out for longer periods of time.